circumference, we're not finding the area, we're graphing circles.
Oh, but usually pi's thrown in there every once in a while, no matter
Pi
what.
is used when you're finding the circumference of the area. We're not doing that. We're just gonna graph them, and then we're gonna write equations of them, given certain bits of
I
information.
used to be able to recite so much of pi, and I only know a little bit.
So the first thing you're gonna do when graphing a circle is the first thing you would do for parabolas. In parabolas, we graph the vertex. In this case, it's not a vertex, but it's the same like critical point. It's our center. So it's the thing that like everything is centered around. So your center is HK. H is whatever is being subtracted from X, and K is whatever is being subtracted from Y. So 1 is being subtracted from X, and technically a -2 is being subtracted from Y. It says Y plus 2, so that's going to be a -2. So that's your center. Next thing you're going to do is identify the radius. You need the radius in order to graph it, because you need to know how big it is. So it's always equal to the radius squared. So you're going to take whatever that number is and square root it. Now, if it's a perfect square, great. If it's not a perfect square, you're going to guesstimate. You're going to use your like skills of square roots to guesstimate. So this is a perfect square, and it's 5. So our radius is 5. If it's, say, the square root of 26, then you're going to guesstimate based on other perfect squares that you know. So, for example, you're going to compare that to the square root of 25 and the square root of 36. We know that the square root of 25 is 5. We know that the square root of 36 is 6. That means that the square root of 26 is somewhere in between 5 and 6. It's closer to 5 than it is to 6, which means the square root will be closer to 5 than it is to 6. So you're going to guesstimate. It's probably like 5.1 or something, and that's what you would use to graph your radius, something close to that. It doesn't have to be perfect, obviously, because you don't actually know what it is, but that's what your logic would be behind that. You're comparing it to two square roots that you know. Let's say it's like in the middle. So maybe it's like the square root of 45. What's a perfect square that's near 45?
49.
49.
7.
And then what is that? Yeah, 7. And then what would be one right below it?
6. 36.
So it's literally like right in the middle, kind of, right? It's like 4 away from that, and it's like, I guess it's a little bit more. So it's closer. It's closer to 7 than it is to 6. You're just gonna guesstimate. You can guesstimate anything if you want it. Yeah, if you want to just make it nice and easy, you could just guesstimate 6.5.
I like this.
You're literally guessing. And this is in the situation where you don't have a calculator.
Oh man! Oh, so there's no calculator.
Well, wrong answer would be like
way off.
8.5.
If I said like 6.4.
No.
No, she said you can do that.
Because you're not gonna know. There are like techniques that we use, but they involve calculus to guesstimate what this is. You're not gonna know those techniques.
What happens when I
obviously.
guess?
So you're literally just guessing something in between these numbers. There's not really a wrong answer. A more wrong answer that wouldn't necessarily be wrong would be like 6.1, because that's like way too close to 6.
But like you couldn't like take points off, could you?
No, not really. But like I said, like a wrong answer would be like 6.
Yeah.
That would be a wrong answer, or
What about
7.
7? Oh.
That would
So
be
it
a
has
wrong
to be
answer.
decimal,
There would have to be
basically?
something in between. Now, graphically, you're not going to really be able to graph that accurately anyway, so it doesn't really
I'm
matter.
probably just gonna do like stick with like 4.
Yeah.
So make it easy for us.
And then in some situations, well, we'll get there, so never mind. I won't get there yet. All right, so let's graph it. So we're going to graph our center. So center is at 1, -2. Now,
Very cool.
I graph my centers with an X because I don't want to confuse them with other points on the graph, but you can graph it with a point, whatever you want to do. You can maybe just use a different color, or you can just graph like a dot and put a C for center. But sometimes when you start graphing, you get confused what your center was. So that's bad. You don't want to like accidentally move your center and then everything's wrong. So do something that distinguishes it as a center, like it makes it.
Is this gonna
Make
be
it a
big?
C.
Like how big do I need to make my graph?
Well, the radius is 5, so if this is at -2 and we walk out 5, that's going to bring
Oh,
the farthest point at 7.
I need
So
to.
your graph needs to go at least to -7.
I'm just gonna like double them up. Give me a minute.
This is a 7x7 graph, and it's gonna fit.
Mine's gonna be like.
So I'm gonna go out 5 from here too. So that's gonna bring me out to 6, -2. And then I'm gonna go up 5, which is gonna bring me to 1, 3. And then I'm gonna go left 5, which is gonna bring me to -4, -2.
And then what about do you want to do this thing?
Wait, how did you get the other ones?
Just go up 5, left 5, right 5, down
Oh
5.
my god, I thought you were
5 in
saying-
every direction.
And then
from
just draw
the
a
center.
circle.
So then you want it to look rounded, so you're gonna try to like round this off a little bit. You don't want it to look like a square. See what I'm doing? Just kind of like giving
Yeah, you're rounding it off.
a little rounding it off, and now I'm gonna attempt to connect everything
Oh boy.
in a rounded fashion.
I just like can't draw a circle. It's gonna be such a
So
problem.
it doesn't have to be perfect, but it really shouldn't look like a diamond or a square. Like,
Yeah, mine does.
avoid that. So if it does, if you go
Avoid
like
that.
this, and it looks like this, right? Just kind of like pop it out a little bit.
Is this good enough?
Like sketch it out so that it's like more rounded, and then you can go back in here and erase the icky stuff. I mean, obviously you're on paper, so you can't do it with your finger, but
How
it doesn't have to be perfect.
Is
It
this-
just
is this
shouldn't
fine? It
look.
looks like a circle.
Yeah, it just shouldn't look like pointed. Like don't make it look pointy. Another hint, if you want it to look better, is to kind of like round, like so. For example, when you start with your points, you have like this many 4 points. Go to each point and kind of like make a roundedness.
Yeah, I did that and I still failed.
But it helps. It won't look like a
Just
square.
let me see it.
It'll just look like smush.
It looks fine.
Anywho, just some tips. As long as it's not like pointy, it's
Some tips and
fine.
tricks.
But also make sure the points are there. So don't just like put a dot and then I don't want to see a circle. Like I need to see the points because sometimes people do this and their radius will be good here, but it won't be good here because they literally just like only put 1 point. You have to put all 4 points. And at least that way, even if you aren't good at drawing a circle, it's like supposedly accurate.
You know, it's just gonna be rough, but I
But
think it'll
don't
be
just
fine.
like draw a circle with 1 radius, it's gonna be terrible.
You
Anyway,
don't know my
let's
skills.
move on. So let's go to the next one.
My phone is
What would be the center if there's nothing here with y? 0, just 0.
Oh my
So here we have x plus 3, which would make our x coordinate -3. And since there's no parentheses with some kind of number subtracted from
Should be
y,
0, 0.
it's just going to be 0. Well, it's going to be -3, 0. So 0, 0 would be if it was just like x squared plus y squared equals 16. So I'm going to graph that right here.
Oh, I have to draw my graph. Everyone hold on.
Well, let's all wait on you.
Thanks.
Wait for Emma!
This is like, you just go very fast. And I like making my graphs really perfect.
That's where
so,
we print the notes.
But, you see, I don't have a printer in my house that works.
What
Now-
would be our radius?
4.
Where did you get that from?
16.
Anyone?
Oh yeah, sorry. I
So you
forgot
just
how
square
to
root 16 to find your radius.
Right.
Be careful, like sometimes people don't square root properly or they say like silly things like if I put an 8 there, they'll say 4.
Me.
But remember, the square root of 8 is not 4. The square root of 8 is one of
3.
those awkward numbers. Yeah, that's really close to 3,
And 2.
but not quite. So it's like 2.8 maybe. I don't know. We're going to go 4 to the right, put a dot. We're going to go 4 down and put a dot. We're going to go 4 to the left and put a dot. And then we're going to go 4 up and put a dot. And then we're going to kind of round off our little points so that it doesn't look like a square.
Oh my god, mine literally, I just drew a straight line. I'm so dumb.
And then I'm going to kind of like...
Yes, Emma, it's a diamond now.
It's a rhombus.
Now it's too round. What is going on?
How do you, what?
Like, I rounded it out too much. I don't know. I don't know. Don't ask.
If geometry should have taught
So
me anything,
pretty.
it was to draw a perfect circle, and it clearly didn't do its job, so.
Nah.
I'm struggling.
I just realized that. Alright, so they're gonna give you some pieces of information and you're gonna make the equation. The nice thing about circles is there's only one circle equation, so it's one thing that you have to memorize. Please memorize it tonight.
Will do actually.
especially since you have a quiz Friday.
Oh, we do. Okay.
Will this just pass through? Does it just stop?
I'm getting there. So this particular question says that we have a center at 2, 1. So 2, 1, center. And then it says that the circle passes through 6, 4. So 6, 4 is 6, 4 is here. If the circle passes through it, that means it passes through it. What does it mean to pass through something?
Pass by it.
I can't define the word with the word.
To pass in it, like to go absolutely
The line
through that thing, like into
So
it.
if the circle passes through
In
that,
and out.
it means it has to go
In and
through
out.
it. Now what's it gonna do? It's gonna circle around the center like this. When it tells you that it's passing through a point,
Why
it's
was that circle the
giving
best one
you,
I've done?
it's giving you that information so that you can determine what the radius is, okay? So if it says that it's passing through points, it's giving you that information so that you can find the radius. You know the center, and you know that it passes through that point, so the distance between the center and the point that it passes through is your radius. This is where we use the distance formula. Now, let's just go ahead and plug in our center real quick. Our center is 2, 1, so we're gonna put 2 and 1 in there. And then we're gonna solve for the radius. Now, we don't need the radius, we need the radius squared. Okay, so if the distance formula, I'm gonna do this over here. Distance formula is this. This is the distance between 2 points. We don't necessarily need the distance. That would be the radius. What we want to plug in is the radius squared, not the radius. So we're going to square this distance formula and get rid of the square root and just plug in what we get.
Wouldn't it be d squared?
Here. Yeah, but this is the radius squared. So by squaring this, we can just find the radius squared and then plug it in directly. And then we don't have to like square root it and then square it after that because that's annoying. So we'll find the distance between 2, 1 and 6, 4. We'll subtract the x's in no real particular order because you're going to square it anyway, so if you screw it up, it doesn't matter. But you're supposed to go the same way. And then you're going to subtract the y's. And then math, using PEMDAS. So you'll do parentheses first.
Did you wait? You changed the D to R.
I know,
Yeah.
because that's what we're solving for. The distance squared between here and here, which is representing our radius squared.
16 plus 9, 25, so r is 5.
But we don't want r. We want r squared, because that's what we're going to plug in. But yes, the r is 5. So if you had to also graph this, that would be good to know. But we don't have to graph it. We're just plugging in r squared. You don't have to do this. You can just use the distance formula, but then you're going to wind up getting that r is 5, and then you plug it back in, and you're going to have to square it. So it's like you're undoing something that you're going to have to redo, which is silly. Might as well just skip that part. So that's how you would find the radius in any situation where it tells you that it passes through a point. Sometimes it'll just tell you that it passes through 2 points like this, okay? And so that would give you a diameter. Or sometimes I guess it would give you a diameter, only if they're across from each other. I guess it could give you like this, and then we would maybe do something else. But sometimes they'll tell you like endpoints of a diameter, like this. Endpoints of diameter, like this. And so in that case, you can find the diameter and then just like chop it in half or something. You can also find the center and then find the radius. So I think there's an example like that. We'll get to it eventually. Now for this one, it says that your circle has a center of -4, 7. Here. So all the way up here. And that it's tangent to the x-axis. So what does that mean?
There's a dot on the x-axis.
Yeah, it means that your circle touches the x-axis at one point. So that's what tangent to. To touch at one point. So that means that, so where's the x-axis first of all? Yeah, below it, right here. It means that your circle has a point on the x-axis directly below your center, like so. This makes the question super easy if you understand the verbiage, because what's this radius? 7. Because this point up here, you were on the right track, kinda. So this point is at -4, 7. If it's at -4, 7, it's 7 above the x-axis. And then you can just like write your equation. Right. So we'd have x plus 4 quantity squared plus y minus 7 quantity squared. And then equals 7 squared, which is 39.
That was an easy one.
So when it says tangent to, you're looking at either like a vertical distance or a horizontal distance. So if it had said tangent to the y-axis, then it would have been 4, because that would have meant it's touching the y-axis. That's not a circle, but you get what I'm saying. And so then this distance would have been 4 if it was tangent to the y-axis. So the nice thing is it's just either a horizontal distance or a vertical distance, so you don't really need the distance formula. You can just like count or subtract in one direction. You don't need both directions. The reason we need the distance formula is when it's like a slanty distance, that's when you need the distance formula. But if it's just a horizontal, vertical distance, you can either just count it on the graph, or you can just subtract like just those two, like the x's or the y's or whatever. Okay, make sense?
Indubitably.
Alright, so that's what it means when it says tangent to. So the words passes through and tangent to are hints about trying to give you the radius. Alright, see if you can do the try. Therefore, we're trying to take something that's written out so that you can see each individual term, and we want to group it so that it's in standard form where it's like stuff squared plus stuff squared. So the first thing you're going to do is write it in descending orders while kind of grouping the x's together and the y's together. So put all the x's up front and then the y's like in descending order. So we're kind of grouping these.
Oh, don't you just kind of like move the 15 to the side?
So,
Like factor out a y.
what we have to do here is complete the square. So what we're going to do is leave a space here, leave a space here, and then you're going to add 15 to the other side to get it out of the way, because it's in our way.
Oh.
Don't leave. We're going to complete the square by we're completing the square for each variable. So we're taking half of 2x, or half of 2, which is 1, and then we're going to square it. That gives us 1. That's what we're going to add here. Remembering that whatever you do to one side, you also have to do to the other side.
So the other one's plus 4.
So we also want to complete the square here using the same process. Taking half of this number, which is, and then you're going to square it,
Positive 4.
making sure that whatever you add to the left, you add to the right.
Oh, right.
Then you're going to rewrite these in their perfect square terms, like so.
So it's x squared plus 1. I mean x plus 1 squared.
So this one's going to be x plus 1 squared. This one's going to be y minus 2 squared. And then equals, yeah, because 16 plus 4 is 20. Doesn't necessarily have to be the perfect square for
Oh,
your
and that's like the
radius.
end, because that's the
Exactly. So you're completing the square and then writing it as their binomial squared like way. Like I said, this does not have to be a perfect square, but what it does need to be is positive. If it's not positive for some reason, it's probably because you forgot to like add this to the other side. Sometimes that happens. So it shouldn't be 0, it should be positive and greater than 0. If it's 0, then there's no radius and there's no circle at all. All right. So diameter endpoints mean that it's gonna pass through the center, like specifically, like that diameter. So if we have one at -2, 3, and then another at 4, -5, your circle is going around through, whoa, that's terrible, but you get the point. It's going to pass through those points, and if this is a diameter, in order for it to be a diameter, it has to go through the center. Now they don't tell you the center, but we can use those 2 points to find the center, because the center is the midpoint of those points.
Should you just subtract and divide by 2?
You add and divide by 2 to find the midpoint, because you're averaging. So if you have this point at -2, 3, and this point at 4, -5, you're gonna find the center by doing -2 plus 4 divided by 2, so the average of the x's, and then 3 plus -5 divided by 2, so the average of the y's. So that's gonna give us 2 over 2, which is 1. This is gonna give us -2 over 2, which is -1. So that's my center. That's technically the midpoint formula. I didn't write that down for you, but I do think it might be on the notes. But the midpoint formula is like, it's just this complicated looking formula, and all it means is average. You're just averaging the x's and averaging the y's, or it's like the arithmetic mean. Okay, so try not to overcomplicate that. We literally found the middle just by adding them up and dividing by 2. Like you would find the middle for literally anything. So that's your center. So we can do x minus 1 squared plus y plus 1 squared equals. And then now we would need to find the radius. There's 2 ways you can find the radius. You could find the diameter and chop it in half, or the easier way is once you find your center, you can find the radius by finding the distance between your center and one of these guys. Either one, right? Because it's going to be the same thing. So we're finding the distance between our center and one of the diameter endpoints. Either one doesn't matter. So usually I try to pick like the smaller one or like the less negative one. So there's no less negatives in either, but I'll pick the smaller one. So we're gonna find the radius squared instead of just the radius by doing 1 minus -2. So I'm doing 1 minus -2. Then we're gonna do -1 minus 3. So 1 minus -2, -1 minus 3. And that's going to give us our radius squared. So that's going to be 3. This is going to be -4. This is 9. This is 16. And we get 25 again. Look at that. It's just a popular number. I think I remember this from last year, and I just did like 25 everywhere. That was just crazy. It's just was like a day I was obsessed with 5, I guess.
Just a coinky-dink.
The other way to do it is you could find this distance, not squared. You would literally find the distance and then cut it in half. That would give you your radius. So you would have done the distance formula between your diameter endpoints, and you would have gotten the square root of 100, which is 10. Then you would chop that in half to get 5, and then you'd square it to put it in there. That's the other way to do it. I think that way is a little bit harder because you're like doing a couple extra steps. This way is the more direct way. But either way, it works.